Hello guys and welcome back to this amazing channel. This is Abhinav. In this particular video, we'll discuss about the Leetcode Biweekly Contest 129. Yes, we'll discuss about the problems of this Biweekly Contest 129. The editorials and solutions of the first two problems are already present on our site, which is Coding 75. So if you will see the site, if you will open the Leetcode Contest editorial section, you can see that the first and second problem, which is make a square with same color and this right triangle, these both the problems are already present here with their video editorials, so you can check out both the problems from this particular website. I will provide the link in the description, right? In this video, our agenda will be discussing about these two problems, the last two problems of this particular contest. These both the problems were guys, by the way, of good level. They were both of 3D DP. So this first problem I have solved using recursive 3D DP, and the second problem of this I have used iterative 3D DP, the same approach, but I've added a one extra logic because of which this problem is solved, right? Because it has some extra test cases. If you will see, the problem statement of both the problems, find all possible stable arrays 1 and 2. The problem statement is exactly same. The only difference is their constraints. So if you will see here, the constraint value is up to 200, but here that value is 1000, right? That is why we have to add some extra, thing here to get it solved, right? So let's see how we can solve this problem. Let's first start with the very basic problem number first, which is relatively easy from the second one. Okay, what the problem number first says? Problem says that you are given with three things. Okay, what you are given with? You are given with a number 0, a number 1, and a limit, right? Now what you have to do is you have to actually create a binary array. You have to create a binary array. Now what a binary array is? A binary array is an array that contains only zeros and ones. That is what a binary array is, that contains only zeros and ones, right? Now you have to create a binary array that contains this number of zeros, means this zero number of zeros, and this one number of ones. That's the first thing. Means the overall size of this array should be 0 plus 1. Okay, that should be the size of this array. And the next condition, the third condition, the very important condition is that each subarray of array with size greater than limit must have both 0 and 1. So if there is any sub array in this array with size more than limit, that should contain both 0 and 1. Either one, like basically that should not contain same character. There should be no subarray with size more than limit that have all the ones or all the zeros. Both 0 and 1 should be present in any order. That doesn't matter. You have to return number of such stable arrays. So we call this type of array as a stable array, and we have to find number of such subarrays that are possible. So this is a kind of a problem of permutation combination plus DP is added here. Let's see how we can actually solve it. So see guys, what we actually do is देखो, for example, this is given to us. Okay, for example, the 0 we have, let's say we have uh, 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 10 zeros and we have 15 ones. Means we have to create a binary array with 10 zeros and 15 ones, right? And let's say our limit is 5, or let's say 4. That means we can have continuously 4 zeros or continuously 4 ones, but we cannot have more than 4 continuous zeros and continuous ones. That's actually the real meaning of this third property. This third property says that there should not be any subarray of size more than this limit which has all the ones or all the zeros. It should contain both 1 and 0. On the other hand, we can say, on a contrary note, we can say there should not be any subarray more than this limit which has all the zeros or all the 1, or we can say that 0 and 1 should not be present consecutive time more than limits. That is what I can say. If limit is 4, that means in our final binary array, 1 can be present consecutive 4 times at max, and 0 can also be present consecutive 4 times. 1 cannot be present more than 4 times like this. It's not possible, because if it is present more than 4 times, that means there is a sub array possible which is having all the ones. which is having all the ones and which is greater than size 4. So up to 4 it is possible. You can take consecutive ones and consecutive zeros up to size 4. But more than 4, you should not take it. Otherwise, it will exceed the limit. It will exceed the limit. Simple. The very simple, the very basic approach. Right. Cool. Cool. बहुत बढ़िया. Amazing. अब देखो see. We know that we cannot have more than 4 ones or 4 zeros in a row. Right. But we can have 1 0, 2 zeros, 3 zeros, 4 zeros, and so on. So see guys, there will be multiple possible approaches what we can do. Let's say we started from a 0. So when we have started from a 0, what we can have? We can have a possibility where we have only 1 0. We can have a possibility with starting from 2 zeros, starting from 3 zeros, 3 zeros, and starting from 4 zeros. After that, we will have some ones. Now again, either we will have 1 1, 2 ones, 3 ones, or 4 ones, not more than that. And same for every 1 1, 2 1, 3 1, and 4 1. Same for here also. Now here also, up see, now the last element was 1. Now we will start with zeros. We cannot again start with 1, because if we will again start with 1 and we will have 4 1s, so it will become 5 1. So now 1 1 is done, again zeros will start. So 0 0 0, 1 0, 2 0, and obviously by doing this we have to take care of one thing, that there should be total of 10 zeros and 15 ones only, not more than that. If this is also happening, then also it's not a right thing. So guys, this is how what we will do. So we will guys actually use a recursive approach to solve this problem. Recursive approach. So if you will see what I have actually done here is, so first of all, let me explain you this code. And so for now I am removing this memoization. I will add it later. Otherwise it will be very complex for you guys to understand. Okay. Now see. For now, forget about this DP array. Forget about this memoization. Just simply see that I have created a solve function. Now what this solve function is taking? This solve function is taking number of ones we have, number of zeros we have, the limit, obviously, number of ones, number of zeros, and the limit, and it has a boolean ms. Now what is this boolean ms? This boolean ms is telling what is the number that we have taken previously. Means what should be the number that I can take in this particular recursion call. For example, I told you here, the last number that I have taken is 0. So now you have to take what? 1. And so on. Are you getting? Now you will take 1. So here ms says that if I have taken ms, that means previously I have taken 0 if ms is true. Ms means, if ms is true means previously I have taken a 0, means I have made a recursion call for 0. So now take a 1 only. 1 or like any ones up to limit. And if it is false, that means now take a 0. So if you will see what my recursive code is doing, see, simply if my 1 is 0 and 0 is 0, means if I have created already, if I have checked already a binary string with all the ones and all the zeros, simply return 1. Answer is 1. Else what I will do? Else my answer will be 0. First I will check this. What is this? If my ms is true. ms true means previously I have taken 0. Previously I have taken 0. That means this time I will take 1. And how many ones we can take? We can take ones, how many? We can take 1 1. We can take 2 ones, we can take 3 ones, we can take 4 ones, up to limit. We can take ones less than equal to limit, or less than equal to how many ones we have. That can also be a possibility. Let's say limit is 100, but we have only 5 ones. So we cannot take 100 ones, right? So what we will do? We will run a loop from 1 till the minimum of 0 and limit. Whichever is smaller, we can take that much number of ones. So first we'll make a recursion call for this same solve. Oh, okay, here, we were here, okay. When mn is true, we'll take 1, okay. So previously we have taken 0, means now we'll take 1. So I will take a minimum of 1 comma limit. Now first I is 1. I1 means I am considering a case where I have taken just 1. And now I will make this ms false. That means the next recursion call that will go, it should take 0. It should not take again a 1. Right? So ms true means take a 1, ms false means take a 0. So here I have taken a 1, I number of ones I have taken, and then for next recursion call I made it false. Similarly, when I will 2 means I have taken 2 ones, and for next recursion call I will make it false means take a 0. Similarly, when ms will be 0, I am saying now the same thing happens for the 0. Okay, I will take how many zeros? 1 0, 2 0, 3 0, 4 0, up to whatever the limit is. I can take that number 0. I will make recursion call for all. And now, because currently I have taken 0, means the previously, so false means previously I have taken 1. So if previously I have taken 1, now I am taking 0. And next again I have taken 1. So make it true. So that it should take 1. Okay. And finally, your answer will be answer mod. Okay. But obviously this will not give you right answer. Why? It will give you TLE, because here we are not considering the overlapping test cases, just like in DP we did. So what we can do in case of DP, we can simply check if DP of 1 0 and whatever the limit is. So okay, you can see that's not limit, ms, because limit is not changing. These two things are changing. If it is not equal to -1, if it is not equal to -1 means we have already found it, simply return it, else assign it to the value and then return it. So this is how we are solving this problem. And you can see when I'm calling this solve function, I'm calling for both true and false, means I'm taking that case also where we are starting from 1. True means start from 1 and false means start from 0. So both the cases I'm taking, and then the addition of both the cases will be my answer, right? So if you will see, if I will run this code, it's accepted, and if I will submit it, all the test cases have been passed, right? So this is how we are solving this particular problem. So this is a problem where we solve it using recursion, right? The next problem is this, which is find all possible stable strings second. Now what this problem is, this is a very exactly same problem. The only difference is here test cases are high. Up see guys, here also the logic is exactly same. We will do the same. Okay, for every 0 and 1, if previous was 0, next should be 1, and how much 1 we can take up to limit. But we have done some optimization here so that it can work for this particular test case. What are those optimization? If you will see the code, the very first thing is that, so this is a simple DP vector, just like we have taken there. Simple DP vector is there. So this is nothing. This is not a new code. This is just the same code that we have done previously, but now this is in a iterative way. So previous was a recursive DP. This is a iterative DP. So I hope you guys know how to convert recursive DP into iterative DP. But still there are some changes that I will explain you. It's not just the conversion. There's extra some property also that we have added actually. So what the property is basically, see, first of all, we are taking a DP vector of size by 0 plus 1, 1 plus 1, by basically of size this only. So of size this 1 0 and ms. ठीक है, यहाँ पे it is greater, यहाँ पे 1000 तक जा रहा है, वहाँ पे 202 था, right? So first what I am doing is, first initially all the values of DP, if you will see, is 0, will be 0. दिख नहीं रहा है, but it is 0. Okay. Now what I will do, for all x between 1 to limit and for all the y between 1 to limit, I will make my DP1. और वो DP represent करती है. This DP is representing, let's say I am saying DP of I, J, and let's say this is K. So this K will represent what was the last number that you have taken, whether it was 0 or it was 1. There are two only possibility, right? So this K will be either 0, either 1. It's of size 2 only. I represents how many number of ones we have taken. J represents, okay, so I represent how many number of zeros we have taken, and j represents how many number of ones we have taken, right? That is what it is. So we will see what this DP is saying. It is saying when number of j's are 0, when number of j means number of ones are 0, means if we have not taken any 1 before, if we have taken all the zeros before, so how many zeros we can take before? We can take zeros only up to a particular limit. So for all the continuous 0 from 1 to that limit, I will make my dp1. Means there is one possible array, there is one possibility of an array between if the number of ones are between 1 to a limit, and same happens for number of 1. Okay, this is for number of zeros and this is for number of 1. So this first represents 0, second represents 1. This is a base case that I have handled. Now next what I will do is, next is basically we are like doing the same thing. So if you will see here also, for every 1 and 0 we are checking. So here also we have done the same thing using the for loop. So first for loop is from 1 to the number of zeros and 1 to number of ones. Now this is the very important point, guys. Check it very carefully. Here we are first checking for zeros and here we are checking for ones. If you understand this, you will understand what we are doing here and how we optimize it. See what I am saying. What I am saying, dp of I j0. What's the meaning of this? This is saying dp of ij means if I will take I number of zeros and j number of ones, and the previous number I have taken is a 0, if I am assuming that, means I am taking a 0 now. इसका मतलब क्या है? If I have I number of zeros, j number of ones, and the current number or the previous number that I have taken is 0, मतलब आप क्या कर रहे हो? Means you are saying that now I am taking 1 0. So if you are taking a 1 0 now, how many number of binary subarrays will be there? So if you are taking 1 0 now, either previous was also a 0. So for example, currently after taking 1 0, you have I zeros and j ones. After taking this 0, you have I zeros and j ones. But previously क्या हुआ होगा? Before that there must be I minus 1 zeros and j ones. That is why when you taken one more 0, now there are I zeros. So dp of I j0 is nothing but dp of I minus j0, means previously must be there will be I minus 1 zeros. Na? That is why when you taken one more 0, it became I. Only this 0 will change, because previously there can be two cases. Either previously there are I minus 1 zeros with a 0 at the last, or there are I minus 1 zeros with a 1 at the last. Any one of the both the thing can be happen. So we will take addition of both. But in this case what can happen is, for example, if previously let's say the case was like this, and let's say your limit is 3, and if you have taken one more 0, it will become like this. That means 4 zeros come, which is more than limit. You have to subtract this case, simple permutation. So first you have taken all the cases, you have added 0 to it. Either it is a 0 at the last or it is a 1 at the last. But there can be a case where there are 3 zeros already, which is up to the limit, and you added 1 0 extra. So you have to subtract these cases where we have how many zeros? Limit number of zeros. So what we are actually doing here is, you will see, this is actually we are doing here. So we are subtracting I with limit plus 1. Why limit plus 1? Because limit, we are taking that case where we have taken limit plus number of zeros. So limit plus number of zeros we have taken. तो what, how many sub arrays were there which were I? को I हमारे अभी के zeros हैं और limit plus 1 हमने लिए हैं लास्ट, जो हमें हटाने हैं. तो ऐसी कितनी सब arrays थी? We are subtracting it from there. So first we have taken all of the. First we have taken everything in our answer. But now we are removing those answers that are not valid, which has more than limit number of consecutive zeros. And similarly for 1, if we are taking a 1, previously there should be j minus 1 ones present. We have taken one more, it becomes n. अब last में 0 है कि 1 है, it depends. And here also the extra case is subtracted. This extra case is subtracted. अब ये actually हो क्या रहा है कि see, currently you have I number of zeros, but that I number of zero they can have limit plus 1 zeros in a consecutive way, but we cannot have limit plus 1 0. Max we can have limit 0 only. So we are subtracting that case, which is dpi minus limit plus 1, means that case where we have this much number of thing, वो हम subtract कर रहे हैं जिसमें हमने remaining zeros लिए थे, that we are subtracting, right? So I hope that this is clear. And at the last, we are simply adding dp0 1 0 and dp0 1 1. Just like here, you can see we are calling for 2, right? 0 1 true and 0 1 false. Same here. We are calling for both 0 and 1. And we are adding the answer. So it is nothing but it is just the iterative way of implementing this with the extra logic here. This is the extra logic we have added, right? So maybe guys, this was actually a very hard problem. I tried my best to explain you, and I tried I have also written a very clear solution. I hope it is clear, but still if there's any doubt you guys have, please comment down your doubt, or you can also join the Telegram channel and ask your doubt. Thank you for watching this particular video. See you in the next video. Thank you.